In this section, we cover all the foundational commands needed for daily work with Git. Some of the things we cover in this section include creating a fresh new Git repository, setting up Git with an existing project, informational commands like status, show, and log, working through the basic Git workflow, which includes adding files and committing them into the Git repository, working with other file operations like renaming, moving, and deleting files in Git, excluding unwanted files from the Git repository, and undoing mistakes. We will also learn several tips and tricks along the way. At the end of this section, you will have a strong foundation in Git. Welcome. In this video, we're going to get started by creating a new Git repository locally. Fire up your terminal. You can see that I have my standard directories that I have that are part of a new installation of the Mac operating system. I want to create a location for all the Git projects that we have. Let's create a directory called Projects. Great, now the Projects folder is there. Let's go into it. As you can see, we're in the Projects folder within the user's home directory. Now I'm going to use the git init command to create a new repository within the Projects folder. Type git space init space and then the name of your project or working folder that you want to create. For this example, I'm going to use demo. Git responded by saying it initialized an empty Git repository within the demo folder. If I do an ls, you can see that I have a demo folder. If I go into that demo folder, my prompt changes to reflect the fact that I have a Git repository that is on master, which is the default branch name that you get whenever you create a new Git repository. If I do an ls-al, I can see all the files and folders that are part of this repository, which in this case, there are no files or folders other than the default .git folder, which is the actual Git repository. Next, you need to know about the 3 local states related to files being managed by Git. There is the working directory, staging area, and Git repository, or commit history. As mentioned before, the working directory contains all the files and folders for your application, which may or may not be managed by Git. Either way, Git is aware of those files. On the other side, we have Git's repository, or commit history, which contains all the committed or saved changes to the Git repository. Anything here is a part of Git's history. In between is Git's staging area. The staging area is used to prepare for the next commit. Files are moved from the modified working directory state to the Git staging area and then finally committed into the Git repository. The 3 states of Git are specific to the local Git repository. I like to tack on a 4th state, the remote state. Although a remote repository is just another repository with its own 3 states internally, conceptually, I think of the remote repository as a 4th state, since most people don't consider something truly saved until it is saved or shared on a remote server. We will dive into the remote repositories a bit later in this course, but for now, we'll stick with the 3 local states of Git. In this video, we're going to continue with our demo repository by adding some files and checking the status as we go along. Anytime you want to check out what's going on in the Git repository, you can use the git status command. Since this is a brand new repository, we are currently building up towards the initial commit. And we can see that we're on branch master, which incidentally we also have in parentheses on our command prompt, and we have nothing to commit because we haven't added anything yet. So let's do that. Let's create a file. Feel free to use the text editor you have configured with your command prompt. So I'm going to type mate space and then a file name to create. In this case, readme in all caps .md. The MD extension is for Markdown, which is a popular file format when working with Git repositories. Press enter. With my text editor, I'm going to go ahead and add some text here. I started this file out with demo project readme with a first level header. Then in a regular paragraph, I put this is a simple readme file. So it's save and then close. Now that we've created this new file, if I do an ls, you can see the readme file listed. And now if I do a git status, I get a very different output. Git tells me that I'm still on the initial commit and I have untracked files, specifically the readme.md file. It also tells me what I need to do next, which is use the add command. So let's do that. Type git space add space and then the file you need to add. This moves the README file from simply being in our working directory, unconcerned with Git, into Git's staging area. So press enter. Now that our README file is in the staging area, we can verify that again with the git status command. Now Git tells us, while we're still building up our initial commit, that we now have changes to be committed. That's Git's way of saying that this file is in the Git staging area. Now we haven't actually committed anything yet, and that's the next step to be made. So now type git commit, and for this first example, I'm going to use the -m option followed by, in double quotes, a commit message to provide a commit message inline on the command prompt. I'm using the commit message first file in demo repo. Once you've done that, press enter. Great. We have a special response from Git for this first commit. In parentheses, it tells me that I have the root commit, and it gives me a root commit ID. It tells me that we changed one file, which is the one file we created, with 3 insertions. Then it returned to the command prompt. Now if I do git status, I'm still on master branch, and I'm back to having nothing to commit since I'm on a clean working directory. Welcome. In this video, I'm going to show you the inner workings of the Git repository. I'm currently in my demo repository, and we currently have one README file, which has been committed. What's interesting is this specific folder that we're currently in, the /project/demo folder, is the working directory of our Git repository. The actual Git repository is contained within the .git folder itself. If I change directory into the .git folder, my prompt changes to warn me that I'm in the Git directory. This is a special directory that Git manages internally, and has several files and folders that are used and managed exclusively by Git. I highly recommend that you just stay out of the .git folder unless you know exactly what you're doing. In future lessons, we may come back and actually edit files within this folder, but I will guide you through that process. Alright, now that we're done looking at this particular .git folder, let's back up to our working folder. To further prove that our Git repository is wholly contained within that .git folder, I'm going to completely remove the fact that this folder is under version control by deleting the .git folder. You can use the rm command, passing in the -r and -f parameters to forcefully and recursively delete anything that's contained within .git. Now press enter. When we return, our prompt removes the fact that we're on the master branch in a Git repository because we are no longer in a Git repository. Now I have only the README file and no .git folder. If I use a git command that requires a Git repository, like the git status command, Git will respond with the fact that it's not in the Git repository. In this video, we're going to add Git source control to an existing folder. I'm currently logged into my terminal in my user's home directory. I have a projects folder where I've been putting all my Git projects. In a previous lesson, we created a Git repository in a demo folder, but then we removed the Git repository entirely. Effectively, what we're left with is a project folder without version control. So let's go into our demo folder. So this is where we're at. So I'm within the demo folder within our projects folder underneath the user's home directory. Here I have a README file, and it's currently not in version control. If I do a ls-al, which lists all the files and folders, including hidden ones, I see there is no .git folder to indicate a Git repository. Also, my prompt reflects the fact that there is no Git repository in this folder or any parents. To place this folder under version control with Git, we use Git's init command. Git init, and then you can also specify dot to mean this current folder. Great. Now Git has initialized an empty Git repository in the current folder. You can see this is signified with a parenthesis master within my command prompt. Also, when I do an ls-al, we see we have a Git folder listed. Using the git status command shows that we have one file that's not being tracked. If you've been following along, you know that in a previous lesson, that particular file was being tracked by a previous Git repository. But since we blew away that repository, we have a brand new Git repository starting completely fresh. This version of the Git repository has no prior knowledge of that README file. In this video, we're going to continue by adding files to our freshly recreated demo repository. As a refresher, we have a single README file that is now untracked. Before we add it and then continue to committing, let's add another file. Let's create a file called license.md. So I'm going to use my make command, space, followed by the name of the file, press enter. I'm just going to put some text in here for now. Once you put something in here, then save and then close. Once back to the terminal, do a git status. And now we have both the license and README files untracked. Now this time, I'm going to add both files at once. I'm going to use the git add command, but instead of specifying a specific file to add, I'm just going to use the wildcard character, period, to indicate that I want all files in this current folder added to the Git staging area. Once you've done that, press enter. Now if we do git status, we can see that both files have been added to the Git staging area. Let's continue forward with a commit. However, this time, instead of specifying the -m parameter to add an inline commit message directly on the command prompt, I'm just going to simply say git commit. That will cause the core editor that has been configured with Git to be used for the commit message. Let's press enter. As I've done previously, I've configured TextMate to be my core editor for Git. So now I can type whatever I want using TextMate as my commit message editor. For this commit message, it's actually going to be multi-line, adding both a README and a license file to the repo. Just use your editor's save function, in my case, Command S. Then close the editor, Command W. Then Git uses whatever you typed in your editor as the commit message. In this video, I'm going to show you the commit history with git log. Currently in my terminal, within the demo Git repository. Since we just performed a commit, we have a clean working directory, so there's nothing else to commit. To prove to you that all our changes that we just recently made are in the Git repository, we can use git's log command to show our listing of commits. If I simply type git log, then press enter. Git responds with all the commits that are part of this repository. Incidentally, there's only one commit. Let's go through it. It starts off with the commit ID. So we have commit, space, and then this long identifier. That's the SHA-1 identifier that's used to uniquely identify commits within a repository. After the commit ID, we have the author, which happens to be me, followed by the date, then our commit message. In this case, we had our multi-line commit message that we entered using our core editor. We can get similar information by using the show command. Just type git show, and it will show the last commit and a diff containing all the changes. To get out of the show command, press Q. In this video, we're going to edit an existing file being managed by Git. Within my terminal, I'm currently in our demo Git repository. If I do git status, we currently have a clean working directory with nothing to commit. When ls shows that we have a license and a README file. Let's update our README file. Type mate space readme.md. I'm just going to add some more text, save and then close. Back at the terminal, I'm going to do git status. And now Git tells me that I have a modified file. So the difference is, in prior videos, our README file was untracked and then it was changes to be committed. In this case, we have a modified file that simply says changes not staged for commit. This is how Git tracks the differences between files that are untracked and tracked files. To tell what files that Git is tracking, we can use the git ls files command. Git tells me that I have two files being tracked, which is the license file and a README file. If I add a new file using the touch command, I can see that the new.file is in my file system. Git sees that I have an untracked file and the modification to the README file. Doing git ls-files still reveals that Git is only tracking the license and the README files, not the new.file. Let's go ahead and get rid of that file right quick. rm space new.file. That's the bash remove command. Now I'm back to simply having the README file changes. And the reason why I go through that to show what files are being tracked is that the next command relies upon any tracked files in order to work. And that is something I call the express commit. And that's when we use the git commit passing the -a parameter. The -a parameter tells Git to first add modified files to the Git staging area and then directly proceed to committing. We can accomplish this with basically a single command with this option. Now you might be wondering, hey, why are we adding a modified file? Well, it's just the way that Git works. So basically the way I look at it is that I'm adding the modifications to the Git staging area and then committing those changes. Let's proceed forward by also specifying our -m parameter that we can actually combine together into a single -am parameter. So we have git commit -am, then space, and then the commit message, updating README. Then press enter. Great, the commit's completed. If I type git log, now I have two commits, with the most recent at the top. Welcome. In this video, we're going to back out some of our changes by unstaging from our Git staging area and then finally reverting our changes entirely. I'm starting off in my terminal within our demo Git repository. We're on master with nothing to commit in a clean working directory. So let's get started. I'm going to modify the README file again, and now I'm going to put some random text, doing something that should be backed out. Save and then close. Back at the terminal, we see that we have our modified README file. I'm going to add that to the Git staging area. But do Git status, we can see that we have our modified file, that is changes to be committed. What if I determine that I really don't want those changes? Well, what I could do to unstage those changes is I could use the git reset command as outlined in the git status command. So let's do that now. It tells us to use git space reset space and the special pointer head in all caps space and then the file to be unstaged. In my case, readme.md. Let's press enter. Great. Git responds with saying that the stages have been reset. If we open up our README file, that text is still there. It's just been unstaged. Back at the terminal, if I do git status, it shows that we have our modified file. But I don't want any of those changes. To discard those changes entirely, I want to revert back to the last known good state of that file, which is back in the Git repository. To do that, let's follow the instructions provided, which tells us to use git checkout -- and the file name. All right, git space checkout space -- space, then readme.md. Press enter. And sometimes with Git, no news is good news. Let's check it out with our git status command. Well, we're back to a clean working directory. What about the contents of that file? When we open up that file, our changes are gone. Welcome. In this video, we're going to play with the git log command a little bit more and then create a git alias to shorten a command down. In my terminal, I'm currently in the demo Git repository. I'm currently on the master branch with nothing to commit since I have a clean working directory. If I type the standard git log command, I see that I have two commits. However, if I use git's help command by typing git help log, I can see that I have lots and lots of options available to me. I'm going to quit out of here. I happen to know the options I want to use. So let's use git log space and then -- one line, which will provide a simplified commit entry, providing a lot of that information on a single line instead of multiple lines. --graph, which will provide an asterisk-based graph denoting our branching hierarchy, --decorate, which will tell us which commits are a part of which branches, and other labels within the Git repository, and then --all, which will provide the history for all the branches that are available in this repository. Let's press enter. Now we have a radically different view of our git log command. This is really my preferred view, and I look at it as a git history, although Git doesn't officially have a history command. That doesn't actually stop us from creating one. Let's do that. We're going to use something called git aliases to do so. To create a git alias, which is basically a new command that is a shortened representation of an existing longer command, we're going to piggyback off of git's config command. The syntax is git space config space -- global, because we want this alias to be at the user level, not at the repo level, space, and then the config key alias dot, then whatever name you want to use for your new command. In my case, hist, space, and then in double quotes, command, leaving out the leading git command. So instead of git log, you just start with log. So in double quotes, I have log space -- one line space -- graph space -- decorate space -- all. Double check that line and then press enter. We can double check this entry made it in by listing Git's config entries, git space config space -- global space -- list, and press enter. And at the very end, you see alias.hist equals log space -- one line space -- graph space -- decorate space -- all. All right, let's test it out. To use an alias, just type git space and then the alias name. In my case, hist. Then press enter. If you are successful, you should have the exact same output as the log command that we had previously. Using aliases does not preclude you from passing additional parameters to the underlying command. So in this case, if I type git space hist space and then the option -- space and then a file, then press enter, the hist alias will pass the -- file name to the underlying git log command, resulting in the git log pertaining to only the license.md file. Welcome. In this video, we're going to rename or move files and delete them using Git. I'm currently in the demo Git repository on master with nothing to commit since we have a clean working directory. Let's change that. Let's create a new file. I'm going to create a file called example.txt. Once I saved and closed and return back to the terminal, so we have a new file. Now let's add the file. And now let's commit, adding example file. Currently, I have the example.txt file in my file system. What if I decide that I don't like the name of that file? Well, I can actually change it using the git commands. And doing so provides some extra advantages over just changing the file within the operating system. If I type git mv for move, we're going to move the file to its new name. So I'm moving it from example.txt to demo.txt, effectively renaming the file. Press enter. With Git, no news is good news, so let's do a git status. Git shows that it's going to rename example.txt to demo.txt, but this change is actually staged, indicated by changes to be committed. If we do an ls, we can see that the file has already been renamed on the operating system. Well, to finish the task, we need to actually commit. Git commit -m with a commit message renaming example. Great. And within the commit, it shows that we renamed the file example.txt to demo.txt with in parenthesis 100% confidence level. That is, Git thinks that this is exactly the same file. If we would have made modifications to the demo.txt file prior to committing, then that level would have been lower than 100%. But what if we didn't want that file at all? Well, we could remove it. Instead of removing it using the facilities provided by the operating system, if we use Git to do the removal, then we get the extra benefit of Git automatically tracking the deletion. Doing an ls, we have our demo.txt. We type git space rm for remove, then our file that we want removed, then we can press enter. It tells us that the demo.txt file has been removed. If we do an ls, we see that we no longer have our demo.txt file. However, if we do our git status, we can see that our deletion has only been staged. To complete the deletion, we need to actually do the commit. Git commit -m deleting demo file. Great, we're back to a clean working directory. Welcome. In this video, we're going to rename and delete files outside of Git and see how Git reacts. I'm currently in the demo Git repository on master with nothing to commit since we have a clean working directory. I have the README file and a license.md file. Let's create a new file using the touch command, touch space myfile.txt. Note, this is not a Git command. This is just a bash command that is used to update or create new files. Doing an ls, we see we have our myfile.txt, and I will use the bash command mv, not the git mv command, to rename the file license.md to license.txt. Press enter. If we do an ls-l, we see we have our myfile.txt and license.md has been renamed to license.txt. Let's see how Git sees this. Well, Git sees the myfile.txt as an untracked file, which is not surprising, but it sees the rename as a deletion and adding an untracked file. So we need to tell Git about our recent changes. For simply having deletions, we can use the -u parameter with the git add command. Type git space add space -u, which stands for update, and press enter. Now let's do a git status. Now we have our changes to be committed, which means it picked up the license.txt file, but it didn't pick up the myfile.txt. So in order to include both additions and deletions, you need to use git add -A. That will cover all types of modifications possible on the current working directory and make those updates accordingly in the Git index. Now if I do a git status, it properly sees the license.md file being renamed to license.txt, and it also picks up the new file, myfile.txt. Again, at this point, these changes are only staged. Let's move forward by committing. Great, now we've committed those changes. What if we determine that we really don't want that myfile.txt? We can use the bash command rm to delete the file at the operating system level. Let's do that. Now if we do a git status, it sees the file has been deleted. Let's stage it. Now if we do a git add -u, it will pick up the deletion and stage it. Now it sees the deleted file and staged it. Now let's commit that. Git commit -m remove myfile.txt. Great, now that file has been removed. In this video, we're going to look at ignoring files and folders that we don't want tracked in our Git repository. I'm currently in the demo Git repository. I'm on the master branch with nothing to commit since I have a clean working directory. Listing my files, I have a license.txt file and a readme.md file. Both files I want in my Git repository, but I'm going to pretend that this repository is part of an application that's contained within it. And as it runs, it's generating logs. So with my text editor open, I'm just going to add some random lines to represent a log. All right, I'm going to save and close this file. If I do an ls, you can see I have my application.log file. And typically, we don't want to store log files or any other files that have been generated or aren't original source that's part of this project. If I do git status, Git sees that we have that application log file. And while I could always try to remember to exclude that file when I'm doing my commits, I know eventually I'll forget and just add everything, and that log file will end up in my Git repository. Thankfully, Git provides a nice facility for excluding files and folders we don't want in our Git repository. It's called a .git ignore file. So type mate space .git ignore, and press enter. And the syntax for this file is simply one pattern or expression per line. I could specifically target that exact file, but more likely I want to target all log files. So I'll use an expression instead, *.log, which means any file that ends with .log will be excluded. Let's save and then close. Back at the terminal, you can see the git ignore is already at work. What you'll notice is that the .git ignore file, itself being a file, needs to be tracked in the Git repository. So add the .git ignore file to the Git staging area, git commit -m, space, and then our commit message, adding ignore file. Great, I'm back to a clean working directory, and our application log file has been excluded. It's still in the file system, but it's not in our Git repository. For now, I'm going to go ahead and just remove the log file entirely.